Hello everyone. I'm going to discuss about insertion an element in the kth position of a given list. For the insertion of an element, let us take an example. In this example, my function name or the predicate name is given as insert underscore at. This is a predicate name. Inside the predicate, there are several arguments. The first argument or parameter given as 5. The second parameter is given as list. The next parameter is value 1 and the last parameter is r, a variable. So let us see what does all these parameters means. So basically, the element is being defined as E, where the value given as 5. The list defined as L, the value given as 1, 2, 3, 6, 7, 8, 9. The position K is given here as 1. The result will be given as R. Now the program logic comes in two lines. The first line indicates the base case, and the second line indicates the recursive logic of the program. Now in the base case, if the position given is 1, then whatever is my element will be inserted at beginning of the given list. So basically that has been done over here. So E is nothing but the element which is actually becomes the head of the given list. And thus by this way, the answer comes in the variable R. So here, once we observe this case, the base case, as K value is given as 1, and we replace all the variables with the given input, so it becomes the first parameter becomes 5, the second parameter is the list, third parameter, it matches with the value given in the query and the value given in the program logic. Once these two values are equal, then only this particular case will be satisfied and the base condition will be executed. And thus, in the result section of the portion, R is being equal as EL, and EL is nothing but E is the element where the element becomes the head of the list, thus becoming the resultant list R. So the answer becomes 5, 1, 2, 3, 6, 7, 8, 9, and this is the output for the given query. Now let us check if in place of 1, if the K position is greater than 1, that is 4 over here. So let us check what happens. Now the element is same 5, the list is also same 1, 2, 3, 6, 7, 8, 9. Value of K has been changed to 4 and R is same as result. Now the program logic starts with the first base case. Now base case does not match, as in the third parameter the base case contains value 1 and in the query the third parameter contains value 4. So 4, 1 does not match, thus base case will be overlooked and it will go to the next logic. And in the next logic it has the rule where value of K greater than 1, if it is satisfied, then only this rule will be executed. So let us see how it is being executed. So replacing all the variables from the given query, so we have equals to 5, and here in the second parameter the list are splitted into two parts, that is head and tail. The head portion is equals to 1, which is being stored inside the H, and tail portion T is becoming a list with the value 2, 3, 6, 7, 8, 9. This is a property of a list. By this way, a list can be divided into head and tail. Head is not a list, head is simply a number, but the tail could be list. Either it can be an empty list or it can be a non-empty list, but tail will always be a list. Now the value of K is 4 and the result section is given as HR. Later on we will see how does this HR gets populated. Now with these values, the rule says that if K is greater than 1, then only it proceeds with the logic. So K is greater than 1 satisfies. Now K1 is being updated with 4 minus 1, and 4 is what? 4 is the value K. So we are decreasing K every time and we are removing a head every time. So last time we had 1, we decrease the value of K from 4 to 3 and we remove 1 from the head, from the list. Thus, with the resultant list 2, 3, 6, 7, 8, 9, we call insert at recursively by providing the values in the parameter as 5 then the updated list, that is the tail part of the list, newly calculated K1 value, and R. Next, by this set of input, it will again start executing from the very first program logic. Since the first program logic mismatch base case does not satisfy with the value 1 and 3, it goes to the alternate section where it put all the values in the required input part and then remove the head. Here the head was 2, which has been removed. Now K has been decreased from 3 to 2. After removing the head, we are left with 3, 6, 7, 8, 9 with the value K1, that is 2. Again a recursive call is being done. Then again it checks with the base condition. Whenever the recursive function is called again, it again starts from the beginning. So here also 1, 2 does not match, so base condition does not get executes, goes to the alternate logic. Here it has 5, 3, 6, 7, 8, 9 and 3 gets divided and stores in the head part. And then K1 is further reduced from 2 to 1. After discarding 3, we are left with 6, 7, 8, 9. So with this tail part and the updated value of K, we are recursively calling insert at function again. Again, it will start executing the base case. And now we see that 1 and 1 matches. Now, since these two values match each other, thus it will store value of in the variable E, the value 5, in the variable L, the value 6, 7, 8, 9 list, 1, 1 gets matched. Thus, it will replace E with 5 and L with 6, 7, 8. Now, we have this result as 5, 6, 7, 8, 9, 5, 6, 7, 8, 9. This is the first result that we got after executing the base condition. Yet, before that, the result was not calculated, but it calculated at the base case. Now again, we go back, we move back to whoever this function was called. So we move back to this stage. When the value of K was 2, and we had a list like 3, 6, 7, 8, 9, where 3 was sent to the head part, at this stage, the rule called the function recursively by a new list 6, 7, 8, 9 without considering 3. Now, whenever this get executed, it receives R as 5, 6, 7, 8, 9 from this base after executing this base case. After executing this base case, here the first time it receives the output. So it passes the output to the caller function and it becomes R over here because it receives in the R variable, because in the syntax it is written as R over here, right? So R is this. So R contains 5, 6, 7, 8, 9. Now, if we again move back to the caller function, the caller function has H pipe 3. So R becomes my tail for this part. R becomes my tail. Now, what is H? H becomes my head. That head I have already eliminated. So now I put 3 over here and R becomes 5, 6, 7, 8. Thus, if I replace this, I get 3 inserted before 5. And I could also say that my K has been updated. Now moving further, we see that this particular input actually called the rule and recursively called this function with the updated value where the list was 3, 6, 7, 8, 9 and the value was reduced to 2, and this R was received from where? From this value. So this is the resultant area or parameter. So this result value will be received over here, because once this is called, it was calculated from this portion. So now R get 3, 5, 6, 7, 8, 9. Now this R again comes over here. H is 2 appends over here, and my result becomes 2, 3, 5, 6, 7, 8, 9 for k equals to 3. Now someone has called k equals to 3. Now let us see who called k equals to 3. 4. When k is 4, it is responsible for calling this particular function. Now again, here the value is 2, 3, 5, 6, 7, 8, 9 that we have just now calculated. Now this becomes R, as we have just replacing this value. Now this R will again go over here. H will come and becomes the final result list. This is our resultant list where 5 has been successfully inserted at position equals to 4.